grumpy side.
And welcome back to the highest of the high-tech science discussions on the internet, Grumpy Science. And we're here again with our new and revamped studio. We now have an extended high-tech multimedia center, and the multimedia command and control center here. You can see it actually has a screen. It's kind of a laptop, but we will show you, and then you won't be able to see some very interesting science that Mark's been working on lately. So
yeah, we've been looking at a lot of things, and
we've been looking at. You won't be able to look at it because we're going to be holding a laptop up and trying to show you. That's
we're gonna focus on this laptop.
That's
it shows up really well.
Yeah, as you can clearly see,
we're going high tech with this
science.
We've got lots of science
here
to talk about,
right.
And we decided what better way to start our new season. I guess the new season just sort of happened because we took the summer off.
If you let me put so this is the new season. We had to kind of recharge our grumpy batteries.
Yeah, I'm grumpier than ever.
And I found out that mine weren't needing of recharge. Mine were just burned out from overuse, so I had to replace them, not recharge them. But here's the interesting thing, okay? And we've talked about this a little bit. Well, a lot in Grumpy Science. One of the reasons we're so grumpy is that a lot of scientists, their idea of doing their work in the context of all the important work means they go back 5 or 10 years, and they lose context. And those who ignore or don't know their history are either doomed to repeat it, or in the case of science, doomed to look pretty stupid.
Yeah.
Right. So one of the things Mark and I do is we actually look at what science was like more than 10 years ago. Right. I mean, further back than the purchase date of our most recent computer. And what's really terrifying, I think is the right word, is when you actually look at how good the science was maybe 100 years ago, and then you look at what they're doing now, especially in biomedical research. Let me put it this way: if you have faith in science, it's terrifying. You'll have nightmares. So because you can prove to yourself without really having to dig too deep that a lot of research, biomedical research, is getting worse decade on decade.
Yeah,
I think that's true.
It's actually 150 years. But
yeah, well, I mean, we look at stuff. You can go back 2,000 years really in some areas and find very interesting insights from Galen, Pliny the Elder, and different, historical scholars of their day, making observations that were very interesting. And you compare what people are finding now with some very old observations, and they really were kind of on the mark, and some were way wrong, right, of course. But and science we used to be self-correcting, where we would find out, well, they were wrong, and we would come up with a better idea. In medical research, it's kind of stopped being self-correcting. Now it's just it's like self-reinforcing, like a bad habit.
Yeah.
Yeah. So anyway, enough grumpiness. Let's get to the science.
At least one grumpy regulatory study. Yeah, we should do that first.
Okay.
Just be grumpy.
All right.
So, obviously we sell the brain gauge, obviously. So, and actually a lot of researchers buy them, and a lot of doctors or clinicians buy them. And recently we had an interesting interaction with presenting our data and showing it to a group of doctors, and they say, yeah, we definitely want to buy these. Well, they were all at one university, and so then they handed over the purchasing to their purchasing agent, who happened to be a lawyer.
Oh, God.
I was like, we got any lawyers watching? Oh, well,
anyway.
Favorite
joke, it's black and tan and looks good on a lawyer.
And so I think the lawyer has spent more man hours on this and his per diem on this than the device actually costs. And all bears down to, if we purchase, will you send it to us? And I was like, well, yeah. And will you support it? Yeah.
That's right.
Yeah, we do that. So this is sort of an advertisement too. If you purchase a brain gauge, we will send it to you and support it. How's that?
Right.
I was
talking about a profession that has to create its own demand.
No kidding.
Right.
And so I think he's actually writing up a contract, which, and to be quite honest, I'm going to raise the price of the brain gauge. They're going to lose their...
I had an engineering company like this way back 20 years ago. It was a really good company. It was in the middle of a cornfield up in Dexter, Michigan. And we used to do our pricing by what we thought would be a reasonable price for the engineering consulting design work, plus $10,000 every time they really did
That's
something
right.
stupid.
Was this
Remember
the AH factor?
Yeah.
Yeah. Okay.
Yeah,
We'll keep it clean.
Yeah, we'll try to keep it family friendly. But if they treated us poorly, we would just tack $10K onto the quote. And we were going to build something for a very large automotive company for $8,000. And every time we went to talk to them, they had some management knucklehead in there who decided to, bully us. So they ended up paying $48,000 a piece. Can you believe
This
that?
was, and the reason, one of the reasons they were bullying them is because the
10,000.
device that you built
They hadn't seen anything
had
like it
zero variability,
Oh,
and the
yeah.
statistician said this is not possible. It has to
It
have
was
0.001
such an accurate
variability.
device that it could detect, it could place itself within 1 micron, 1/1,000,000th of an inch every time.
Yeah.
And so they tried to measure how inaccurate it was, but the device they were using to measure it, this is kind of a good analogy for brain measurement. Okay,
Yeah.
the device they were using to test my device was like 1/10 as accurate. So they couldn't detect the variability in my device, which is about 1/2 of a micron, about one wavelength of light. Okay. No, theirs was good to maybe 10 or 12 microns, so they couldn't detect its variability. So when they did the statistics, they kept coming up with 0. Well, that's impossible. Nothing is perfect. And I said, well, yeah, of course nothing's perfect. Your device isn't perfect.
Yeah.
And then they would be abusive, and then I would say, yeah, this is getting expensive for you. So I was going to sell them, and I would have been happy to, an $8,000 device, but I added 4 times $10,000 to it for every time they were just abusive. So
Yeah, that and that probably led to my pickup truck costing more.
we don't do that to you, though. What we do is that every time some scientist is abusive to us, we just make our device better, and then we forward the savings and the quality on to people who buy brain gauge
While we're
stuff.
speaking of microns,
Yeah.
and what a micron is, this brain gauge, we don't do any product placement here, by the way,
Right.
but this brain gauge actually is accurate within a micron.
That's one of the things about it. I mean, my background and Mark's background is actually in scientific instrument development. So we know how to make scientific instruments and how to make accurate measurements.
Yeah.
And so if you want to measure how sensitive a person is to changes at their fingertips, you actually have to be able to move and control things to within about a micron, which anyone, Bueller? Yes, that's correct.
Yeah.
You in the back? That's 1/1,000,000th of a meter. That's a very,
Tiny.
very small.
But basically, what that speaks to is not so much.
Human
not
hair
just
is like what, 70 microns?
yeah, it's pretty thin. Thinner than my hair, but
Yeah.
I don't have it. So,
Yeah.
but what that
I think
speaks
it's
to, I
safe
mean,
bet.
people, and you might think, why does a micron matter? And it's like, well, you can actually detect differences in microns. Your brain can
is
detect differences.
so wired up.
Now, if you
It
deliver,
amplifies these signals so well that you can tell a micron.
yeah, and if you
That's
deliver
amazing.
stimuli that are just a little bit different in terms of micron, they're a little difference in intensity based on the microns that we deliver, you can tell the difference if your brain's okay. Your brain is all wired up correctly.
You can't. Right, but
Guess
the
what?
device is more accurate in its control than your brain is accurate in its ability to sense and process displacements.
But if I stick you in a
It has to.
scanner, like you were in a
Can't tell.
little while ago,
Yeah.
and deliver
For a long
different,
while.
okay, let's say, and rather than microns, if I deliver a 400 micron stimulus just to one finger,
Is that
finger,
even detectable?
that's detectable.
Barely.
And then I deliver 400 micron stimulus to the other finger, but if I do
can't
it
distinguish.
not just once, but if I do it 20 or 40 times, and then pile up all the averages, I can tell a difference between 0 on one finger and 400 on the other. Whereas you're really good. We are really good at detecting differences. And that's your mental acuity. And acuity is just sort of like turning that contrast knob that us old guys had on television sets.
Right,
growing
I
up.
remember that.
So
Vertical hold.
Okay.
Now, Daddy, why is
So, you have the brightness knob and the
Right.
contrast knob, and they
Right.
all play into how you deliver and give stimuli. Who would have thunk it, that when I was playing with the TV as a little kid, I was a developing neuroscientist.
Honing his skills as a quantitative neuroscientist.
That's right. So anyway, but basically, like I teach a neuroscience course, and one of the things I just ask people, first question I said, how do you study the brain? Every year, without fail, people say, MRI? I said, okay. So in other words, people think you study the brain with imaging. Actually, you don't. You get nice anatomical structures on it, but you really, and some people say you study with MRI, and you do see huge morphological differences between
the differences
one
have to be
population
huge
and
to
another.
see them. That's what he means.
But what you
So
want to do
see a
is,
little tiny difference on the image. The difference has to be huge.
if you want to probe brain function, you have to do something that's more sensitive, and you have to do something that targets particular
Yeah,
interactions.
you got to use the right tool for the job.
Yeah.
So now the point of all of this is that unfortunately the tools for a lot of sort of somatosensory testing were better in some ways,
Right.
150 years ago.
Yeah.
And so Mark is going to show you, without you actually being able to see, these very fine
Well, how close do we have
Pretty-
to hold this?
pastel colors.
see
See
it?
if they were
Can you
bright,
see it?
high
Can you see
contrast
it?
colors. So
Can you
lean
see it?
forward. There we go.
Oh,
Okay.
this is
So,
this
yeah,
is the way
here's
we
our-
do PowerPoint
right.
here
This is it.
on Grumpy Science.
So what we have
So,
here is the year. Notice starting at 1850 all the way up to I think
Today.
it's today. Yeah.
Yeah.
I think this is actually the end of the world. I was seeing that on
Yeah.
Discovery Channel, but here we are today. So
Okay.
so
somebody
excluding
noticed
the
it,
Mayan
yeah.
calendar for now.
Yeah.
All right.
And what we did to get that data.
Well, let me tell them what this is.
Oh, you can tell.
This is years, right? And
Yeah.
then this is reaction time, right? And in milliseconds.
Yeah.
Right. So lower numbers are better, and so you'll notice that more than 100 years ago they were pretty low, and then the average goes up over
And just
time.
to put a number on it, right in 1880s, they did a study on 700-800 people, and average reaction time was 183 milliseconds for men and 185 milliseconds for women. I don't know if they distorted the data so that since the authors were men, they said that.
Well, women couldn't vote back then,
Yeah,
so
so
their opinion
they-
didn't matter, right? And we'll only look at the data that matters anyway, is the men, right?
Yeah.
Just like all of medicine until a
Yeah.
couple years ago.
And their method was with a pendulum-based method that was accurate up to 10 milliseconds.
These people are using basically twine and twigs, all right? And they're getting better measurements than we can get with computers. So now what's the number? So it was
Now-
185 reaction time on humans.
Now, and these numbers came from papers, but these are publications.
Yeah.
We went into the published literature,
Archival record, as we call it.
and said,
scientifically.
okay, and said how many. These are all the different studies people did on reaction time, and they looked at it, and so we pull out what was the average reaction time for the healthy controls.
Right.
Some of these studies were like on comparing schizophrenics to controls, and some people were comparing people with chronic pain to controls. So
Yeah.
we just took control data and plotted it. And so between 1880 and 1970, the average was 185, 190 milliseconds. All of a sudden now,
All of a sudden, about
seeing-
1970, when you could start to buy computers and use them in your laboratory.
right, all of a sudden the numbers start going up. And now
why is
we've
that?
got measures around 400 milliseconds.
Well, so initially,
So why is that? You guys can still see
yeah,
this.
you can
so-
still see like the blank screen with Mark's very pretty looking pastel dots.
Yeah.
That are just well, dim enough that you can't see them. But let me see if I can. There you can kind of see that.
Sure.
So the basic bottom line is from about 1860 until now, until about the 1970s, people had more or less the same reaction time, right?
Right.
180-ish, 190-ish milliseconds. And then starting in the 1970s, reaction times actually started creeping up sort of non-linearly, sort of, to now what?
What is? So there are a lot of articles now saying, "Are we getting dumber? Look at
Right.
reaction time getting worse," and that's reaction time of healthy controls. So there's a couple of possibilities for why things are getting worse.
Well,
And this goes back into the
maybe
regulatory
that
side of
people are,
Grumpy Science
yeah,
too.
maybe people are getting less healthy. Maybe they're not working on the farm as much. You and I have discussed that, right?
Yeah.
They're just not outside enough. They're not doing physical work enough. Maybe there's something wrong with people, or maybe there's something with the wrong with the way they're
it was
measuring.
collected.
Right.
And so when we go back into those papers and look at their methods, oh, by the way,
Maybe I can do a better job with a pendulum and a stopwatch than
Yeah.
we can do with like a desktop computer now.
Now, might mention that the data we get with the brain gauge is more compatible to what we saw between 1860 and 1970.
Yeah.
Just saying.
Just saying.
Just saying.
So
But
okay. So let me stop being too sarcastic for a moment and say if you have the right tool, you can actually take a measurement that is and should be stable over centuries, right, and get the right
Right.
number. But if you're using these commodity grade computer hardware, components, and you think you're doing somatosensory research, ooh, we're going to get a hater for that.
Yeah, we got a hater on this
we've
last
got,
time we mentioned this.
We have haters. I check my mail. I shake the boxes first, make sure nothing loose in there. If you think you're doing somatosensory, function research, and you're using like computer mice and screens to do your reaction times and stuff,
you can actually get a different reaction time by sitting down at one computer and running running a program, getting your reaction time by flashing something on the screen and clicking a mouse, and then going to another computer.
Same brand computer. Thing. In fact, you can get different answers depending upon how much overhead the computer has, because it has to spend,
So I much prefer my changes in reaction time to be due to sleep, or in this past few days, sleep deprivation, or caffeine, or whatever it is you're trying to tune.
This is a chronic, long-standing problem in medical research, right? Is that we're starting to see more and more of certain diseases, and everybody's getting worried that there's more and more of a disease, when in fact what it is the tool that we're using to make the diagnosis, or the definition of the diagnosis, changes, right?
Yeah.
If they want to say, oh, we've eradicated a disease, one of the tactics that's used is actually to change the name of the disease and then call it something else, or split it into 3 or 4 diseases, and then say, well, there's only this one, and notice how the numbers really dropped. And this is a long-standing argument, and it's well documented that and this is just one case where over time the use of equipment that's inappropriate for scientific measurements is causing it to appear as though there's a change in human cortical function, which is
that's what it looks like.
Seem to be the
now
case.
there are some other issues here that are grumpy related.
Right. My other issue is that not only is the equipment worse, but the researchers themselves are less qualified. Right.
Not just 100
years ago, people knew how to build their own instruments.
But 100 years ago, they didn't have a lot of people looking over their shoulder and making them write things. So basically, the way it works now in research is like if you have
you hold back evil.
So university-based research, you've got to get approval to do it, and
rage increasing, vision blurring.
Calm down.
Okay. All right,
we don't want another stroke.
I won't let it. That's all right. I've already had one this year. That's enough. Okay, I'm okay. I'm sort of like Mr. Furious in this famous sort of B movie.
Yeah.
Vision blurring. My superpower is that I can get really angry about stuff, right? That's why I'm a grumpy scientist. All right, I'm sorry.
Yeah.
I like to interrupt.
So people write up their protocols and get it approved by a university committee, and then they have to stick with that. And a lot of times they'll say, we get people in the door who are supposedly healthy controls, but they have some many kinds of neurological disorders, but because it wasn't listed in the regulation that they don't have to do it. Whereas 100 years ago,
they would have one person making reasonable clinical judgments.
One or two scientists saying, okay, what's the best way to do study? And when somebody comes into your study and says, well, I've got MS, is that a neurological disorder? And you go, it might have an impact. So
you note it, you put it in your notebook, and you take the data. It is what it is. And then if you see a pattern later, everybody who says, gee, I think I've got MS, maybe they are all really different in some important way that you didn't anticipate, but you were able to take the measurements you want to take, and then you can detect this. But nowadays, you're really restricted. You can't ask any extra questions. You can't take any extra measurements. You can't make any discrimination between your subjects.
Right. You're locked in.
You're locked in. So even though there's a great opportunity to make a discovery, you're not allowed to do it.
Well, you're locked in, and you're locked into this pattern, but you're also locked in to bring in enough subjects no matter what. Because you said you were going to bring in this many subjects.
So say you're going to bring in 300 subjects, right? And you're on about number 6, and you go, yeah, this is a really stupid study. We need to redesign it or something. But you have to,
right?
You have to march all the rest of the people through.
Yeah.
Even though it should be stopped.
And I'll say this is why we really like doing non-traditional type study venues. But, that's enough said about that.
That's right. We complain about that a lot, and we'll have, in the future, we'll talk about that a lot. But basically, so I guess the, the bottom line is that a lot of things that people are publishing now as like, people's changing in their, some kind of biomedical measurement may not be an actual biological change, but in this case, in the case of reaction time, is actually what's called, scientifically it's called an artifact. It's an artifact of the way the measurement was taken. And it just so happens that a pendulum and a stopwatch give you a better measure of reaction time than a personal computer.
Yeah, and full disclosure, there's another way to get a pretty accurate measure of reaction time.
Okay.
Which has nothing to do with computers or whatever. It's called dropping a ruler.
Oh yeah, the ruler drop. This is a beautiful one.
But you got to use the same rule. You got to use the same ruler every time.
If I had this beautiful wooden ruler, so the
And then you
idea
just
is
gotta
you
do
drop
the
a
math.
ruler and the person has to catch it.
Catch it, and
Yeah, so
but
they
then
see
you
the
just
ruler
gotta
fall,
do the math.
catch it, and then you do some math and you calculate. How quickly does the ruler accelerate down? It's very consistent. It's
you got to hold your hand in the exact same place.
right.
Drop the
Yeah,
ruler in
yeah.
the same
But that's
place.
all. That's all sort of mechanical, common sense kind of things, right? But I mean, how complex is it to get an accurate measure of reaction time? It's exactly as complex as dropping a wooden ruler.
Yeah.
And
by the way,
which by the way is a lot more accurate.
By the way, you can get your reaction time faster just by doing reaction time over and over and over. That's not because you're better at answering the questions. It's better because
your reaction time. Yeah, well, it's exercise, right?
It's a little bit like lifting weights.
It's like if you check every 2 or 3 times a week, you check how strong you are. Guess what you're going to do? You're going to get stronger.
But
What's
that's
the
not
heaviest thing I can lift?
Yeah.
Well,
but that weight stuff's not FDA approved
That's
to
right.
that claim.
Well, you can't prove that's exactly 145 pounds, so you can't make that.
No, you
measurement.
can't prove that you'll get stronger by lifting weights. So
Oh,
you
yeah,
can't
by the
say
way,
that you're that.
Weights are not FDA approved for that medical claim.
So I was just modifying our claim here that we said if you
We're
exercise, you'll get
well,
stronger.
let me be 100% clear. We're making no medical claims. We're complaining about regulatory agencies.
Yes.
That's what we're doing. We're making no
Unless you're from the
medical claims.
FDA and you're watching this, then we're perfectly okay with you.
Oh yeah, we love you. You guys are great. Yeah, but if you're any other normal person, yeah, the big problem is the regulatory, the hobnail boot, stopping intelligent, scientists from making the decisions they need to make and the measurements they need to make to get the right answer. So it's a combination of things, and I still think, and Mark may not agree with me, but I think that a huge amount of what's wrong in science now is that people are very far removed from their equipment. They really don't know how it works. And when I talk to these old-timey scientists, especially people who are 1 or 2 generations older than me, which may include you. I don't know. He's a little bit older than me, but I'm the one who had the stroke. So it's not like in biological years, I'm
he gets a stroke and I have to drive him. Yeah,
that's right. It's an awesome excuse. But the thing is that when you talk to older scientists, they will tell you not just which measurements they took, but how they took that measurement and how careful they were about their instruments. And many scientists were very, very good at glass blowing and preparing their own chemicals. And
or they actually knew how to calibrate their electrodes. And by the way, that's something that we do. We try to take all that out of that. Yeah. This is a self-calibrating device.
Well, see, the thing is, though, but it's been prepared by people who know what they're doing, which presumably is us, right? But there's a lot of science, like cancer research and everything, where the results that people show are actually just artifacts of the scientific equipment and reagents that they buy.
Yeah. Well, we're still here full of it because this is the first show back from a long hiatus, and so
a little extra.
Probably should cut it off now, so we're not way too long.
All right. So, well, we'll stop now. Against my protests, we're letting you off the hook.
Yeah.
At 23 minutes. All right. Bye-bye.
Bye.